this is the first stage of wiring for the electronics enclosure. Okay. I've got my power switch wired up here. We've got the switch and the gland connector holding the power line. And we have our dual set of Wagos for our commons. We've got line 1, line 2, and ground. I'm feeding this 220, so there's no neutral used. Line filter is not wired yet, that's next. Here's the contactor with the wires going into the first two here and the second, or the fourth one here. Wording is hard today, apparently. We've got the emergency stop switches and the start and stop switch set up. And the 1 amp breaker that runs power through the stop switch or the start switch and the contactor. So the next step is to go ahead and plug this thing in and test to make sure that the contactor makes the contact, right? So we're going to go ahead and plug it in. This is a standard 220 volt power plug and a 220 volt outlet. We go ahead and we'll turn the power on and come over here and hit the start button while watching and listening for the contactor to fire. And there we go. The contactor is now doing its thing. If I hit the e-stop button, it releases. Okay. And if I hit the stop button, it releases. So there we go. Now on to wiring up, I think, the power supplies are the next things that get wired in. So I'm going to go ahead and do that. Okay, I have the 24 volt and the 48 volt power supplies wired into the output of the contactor. And I have derated the 48 volt power supply down to 45 volts. As we can see right there, 45, 45.1, it's good enough. And that's it for that task. So next up is wiring the AC inputs to the VFD. Okay, so now I have the line filter and the VFD wired for power. You can see the line filter right here. VFD, these are the 220 volt lines going in. I went ahead and I used a Wago as a grounding terminal here because inside there's only a single terminal there and I didn't want to stack stuff up. So I can use this block to ground both the ground for the coming into the VFD and the ground that's associated with the cable that goes to the spindle. And with that said, let's power it up and see what we get. So, yay, I guess. So that's yet another build task done. I think next I'm going to wire in the fans. They're both 24 volt. I only have one of the two installed. And then I need to wire in the DC power for the spindles. So that's what I'll go ahead and do next. Okay, we are almost done with this thing. I have the FlexiHow installed and it has power. I did a couple of power buses using Wagos. I've got 24 volts up here and I've got my 45 volts for the stepper drivers down here. The stepper drivers are powered, or have power to them. I went ahead and got both fans installed, as you can see. So let's go ahead and power this thing up. Turn that on. I gotta wander all the way over here. You know, the funny thing is that every time that contactor slams closed, it still startles the hell out of me every time. Fans are coming up. VFD comes up. FlexiHal has power. Steppers have power. The fifth one here is not powered yet. It's going to be for my eventual fourth axis, and what I'm going to do is I'm just going to daisy chain power to it because I don't have enough room in the Wago bus that I did, and that's fine. It's no big deal. But that is basically what a PrintNC wiring enclosure looks like when you follow Logan's build design. I've got lots more to do, but those are the major high points. So I mentioned a long time ago in the first video that I did for this wire cutter that I needed to adjust it to handle 24 gauge wire. Well, I got it tweaked, and I'm running wire for the stepper driver interface, and I've got it set to cut 8 pieces per run with a 2 millimeter strip on either end with a 315 millimeter wire length. And to kick it off, I just hit function and we're off. And we're complete. And this never gets old. Sometimes it misses the strip on sometimes it misses the strip, and I'm not sure why, but it works most of the time, so I'm going to keep using it. And it's going to make building wiring harnesses for the F-15 a lot easier, especially considering some of the Canon plugs I have to populate have 125 pins in them, and I need all of them. So yeah. Well, I now have the enclosure is like 99% done. The only thing I have not yet accomplished is to get the spindle cable installed, and that is sitting over there on the table and it's ready to go. But I wanted to show you what the final box configuration looked like, and what I did to make it easier to work on. So what I do is I've got an adjustable leaf out here. So I come down and I pick this thing up like so. That probably looked horrible, but it just hovers in the middle there. It's on a hinge, but it gives me easy access to the internals of the box at a great working height. So let's go over some of the stuff that you probably haven't seen yet and some of the changes that I made. If you remember, this panel last time looked totally different. It was using a different kind of connector, and I decided I didn't care for that, so I went to a 5-pin GX16 instead, and I needed to craft a new plate for that. And when I did it, I did embedded lettering, and I printed that face down on my X1 carbon, and it turned out really nice. So here I've got all of the axis step and direction cabling done. These are plugging into a thing called a driver key that the designer of this enclosure makes and sells. Basically, it plugs right into the green connector and makes this wiring a lot easier and neater. I've got all of the stepper driver interfaces to the GX16s done. I still need to close these up because nothing new is going to get added to there, at least not for right now. This cable goes to this keystone jack, that in turn goes to that cable right there, and it interfaces to that gantry connection, and then there's one on the tool head. But I'm not going to get into that right now because I'm just kind of concentrating on the box. So like I said, the next task is to wire in the spindle cable. I do need to wire some interface wiring for my water pump. My problem is that because the box is running on 220, I don't have a safe 110 that I can pick out of here because I'm not using a neutral. So what I'm going to do is I'm going to go ahead and leave one of these to plug the pump in, but I'm going to replace this with a filler plate that will just take an IEC plug like you'd find on a computer, and that will allow me to feed 110 into the system, and then I can connect the hot lead to the relay in here in order to let the VFD turn the water pump off and on when the spindle is active and inactive. I went ahead and got the spindle cable run, so I figured I'd show you that last installation. I needed to move the RS485 communications cable because it was going through this area, and I didn't want that cable picking up any more noise than it probably already would. And I also put ferrite cores around the 3 leads to hopefully damp out some of the noise. I've got the ground leads, and I've got them tied together just to make it neater, and it goes through its own gland nut over there, comes out here, goes up through the cable chain all the way over to the spindle. So woohoo. Anyway, that pretty much concludes the build of the control box. Next, I think I may show you folks what my complete machine build looks like. But I've got other work I need to finish first, especially my pump. Okay, I would like to show you my completed electronics box with a lid and everything. Okay, so since the last time I shot a video on this, I have got the water pump connected under here, and you can see the wiring for that is over here, the 110 coming in. And then, as I mentioned, I've got an IEC power connection right there next to the plug for the water pump. It is not fused, it's just straight across. Although it's not fused, but it does have a breaker. I added an additional 1 amp breaker for the water pump just in case. One thing that is not clear, that should be made clear, is that there's no overcurrent protection in any of this design. It ostensibly relies on the breaker panel that your power is connected to. If you would like to increase the, I don't know, the safety factor or whatever, I would recommend putting in a breaker similar to this design, but for 220 volts and rated just a little bit less or the same, your choice, as the feed breaker for the 220 volt circuit. And it's up to you guys how you wire it. I'm not going to show you how to do that. I've gone ahead and added this user input jack. It controls, or it wires out to basically a button box that is the start stop cycle and an e-stop. This is the input for the jog 2K, which is kind of a pendant, and then our end stop stuff and a couple of blanks. if you don't modify the original design, the keystone jacks do stick out a little bit. I didn't care for that, so I fixed it. And then I've got the lid all done. The only thing it's missing is a handle. The handle that was in the design is more of a joke than a handle. I mean, it's a tiny little handle that's maybe big enough to hold with 2 fingers, and I guess it's adequate, but it looks ridiculous, so I didn't install it. I do need to add a gasket around that in order to clean it up. And I still need to install or move the front panel VFD, or the front panel for the VFD, to that location right there. And when I do that, then I can call the electronics box 100% done. And that's pretty much all I have for you on the electronics box build. The next video will cover the machine itself and my progress on that. So thanks for watching, folks.